Okay, today we are continuing with solving linear equations, and this time we're looking at examples where algebraic type fractions where the pronumeral is part of the denominator. Now these do present a number of difficulties for some people, particularly people that are not comfortable with fractions, as many of us aren't. Now the principle is basically the same, except this time the first step usually is not to eliminate numbers from the same side as the x, but actually to move the pronumeral or the x or the whatever pronumeral to the effectively to the other side of the equation. Now we're going to do this because we do not want the x value as a denominator. Okay, so what we're going to do to both sides in this case, a little bit like when we're getting rid of a number, here we multiply by, if that was a 7, we'd multiply both sides by 7. In this case, we're going to multiply both sides by x. Okay, so we're going to put a times x here and a times x there. Now once again, just like in one-step, two-step and multi-step equations, these two x's cancel each other out, and we are left with, on this side, just 3 by itself equals 7x. Now it's starting to look like just a bit more familiar earlier, a one-step equation in this case. And so what we have here is this 7 is multiplying the x, so to get rid of that from this side of the equation, we need to do the inverse of multiplying by 7. So that's dividing by 7. So we're going to go divide by 7 here, divide by 7 there. Okay. On the left-hand side here, we are left with 3/7. On the right-hand side, that's 7, that 7 cancel out. X equals 3/7. And that's our answer. 3 is a bit hard to check by substitution for most of us. 3 divided by 3/7 equals 7. Okay. Moving on to a slightly more complicated situation where we have more than one number on the right-hand side where the x. So this is like a multi-step linear equation. Okay, so first of all, it's very similar in the first part. I'll just rewrite the question here with a bit of space. -4 divided by x equals 2/3 or 2/3. Okay, so to both sides again, we want to move this x so that it is no longer a denominator or in the denominator. So to do that, we're going to multiply both sides by x, just like we did in the first example. So we multiply by x, multiply by x. These two cancel each other out. We are left with -4 on the left-hand side. And we can look at this 2/3 x or 2x divided by 3. Okay. Now, we're again a bit like a multi-step question from earlier, that what's happening to the x? It's being multiplied by 2 and then divided by 3. So first of all, we will try and eliminate the 3, the divide by 3, by multiplying by 3 on both sides. Didn't leave myself a lot of room here, but multiply by 3 there, multiply by 3 there. Excuse me. On the left-hand side, we have -4 times 3 is -12. On the right-hand side, we have these two 3's cancelling each other out, and we're left with 2x. Okay, now we want to get rid of this 2 from, we want to do the inverse of this 2 times x. So to both sides, we're going to divide by 2. Okay, divide by 2 here. Oops, divide by 2 on the right-hand side. And what we have here, 12 divided by 2 is 6. There's a negative there, so it's -6. These two 2's cancel each other out, and we're left with x equals -6. Okay, we might go back up here and we might look at this and say, okay, if we put a -6 there, okay, still not sure whether that's right. Well, what if we need to simplify these? First of all, the two negative signs would cancel each other out so that we can make that positive 4/6. And we can see, hopefully, that if you divide by the common denominator of 2 top and bottom, you'll get 2/3. So we can be comfortable that our answer is correct. Okay, now complete exercise 4.2, all of Q9. Thank you.